before I start my conversation, I just want to tell you the importance of singular value decomposition. If you take the linear algebra book, if you take a look page number 386, you will see the images over here. And let me explain this image. At first glance, people think the linear algebra has nothing to do with computerized facial recognition, but it does. When computer takes my picture, computer convert my picture to eigenvalues and then eigenvectors, and then verify my image with the storage data inside the computer to make sure that me is me and you are you. All right, so with that little bit selling piece, I can start the conversation. All right, so my first goal is to use this formula, find u mu. Sometimes I call mu u and u mu, but forgive my absent mind. And this is ATA, A transpose A. So I'm going to rewrite this equation again. Mu sigma V transpose A is equal to mu sigma V transpose. Now, as I told you, I have to isolate mu. In order to isolate mu, what can I do? I can do many things. I can multiply both sides by V transpose, inverse of V transpose. All right, so I have a V transpose. So this cancels out. Alright, so now I can multiply both sides by sigma inverse. So if I do that, I get so I'm separate. So now I fully separated mu. So my mu is finally A V transpose inverse mu sigma inverse. So this is what my mu is. Now let's find A transpose A. So how can I get A transpose A? Let's multiply both sides by A transpose. A transpose A. Alright, so what can I do now? A is equal to mu sigma V transpose squared, not square transpose. So A transpose is equal to V transpose sigma transpose mu transpose. So now A transpose V transpose gonna give you the V sigma transpose mu transpose. Now I'm gonna write A. So my A is, don't forget what is my A. My A is, I'll do my last try, mu sigma V transpose. So I'm gonna write A over here and V sigma transpose mu transpose. I'm gonna write mu sigma V transpose. All right. So now, as you see over here, mu transpose mu is, because mu transpose can be mu inverse, so they cancel each other. So that becomes 1. So A transpose A is equal to V sigma transpose, this is 1, and mu V transpose. Now, sigma transpose sigma is, now I have left with sigma transpose sigma, right? Let me see. Yeah, sigma transpose sigma is squared, because this can be considered as, this transpose is sigma. So sigma transpose sigma is sigma squared. So A T A is V sigma squared V T. All right, so that's it. So this is the vector, and this is the eigenvector, this is the eigenvalue, and this is the eigenvector. So as I told you that eigenvector, eigenvalue, the computer takes our picture and computer convert it to eigenvalues and eigenvectors. Computer check it with the data stored in the computer to make sure that you are you and me is me. And how the computer do that? That's what I'm going to show you. Now I'm going to erase it. I have this proof in the separate video. Because if I do show you proof now, this proof, then the video will become long. So I have this proof in the separate video, so check them out. So I will write these two equations over here. Mu is equal to A V T inverse sigma inverse, and the other formula is A transpose A is equal to V sigma square and V transpose. With these tools, I think we can win the war. Alright, so let's first start with the problem. So our problem tells us that the A 0. So we want to make sure that A transpose A. So A transpose A should be, let's transpose it first. 1 0 1 negative 1 1 0, and A is simply this one, 1 minus 1 0 1 1 0. So this is 2 by 3 and this is 2 by 2. So what I'm looking for is final 2 by 2 matrix. Alright, so let's see how it goes. So I have rows and columns. So 1 times 1 is 1 plus 0 times 0. Hopefully this is right. If this is not right, then everything would be wrong. So now from here we have to find the eigenvectors. So from here we have to find the eigenvectors. So let's first find the eigenvalues. So let's first find the eigenvalues. To find the eigenvalues, we have to find a determinant. So let's see how we can find the determinant. So determinant is equal to, so in order to find the determinant, so this is the lambda. So we're going to set this one. So determinant would be, so this is A, B, C, D. AD minus BC. Alright, determinant is AD minus BC is equal to 0. So determinant is AD is 2 minus lambda, 2 minus lambda minus 1 is equal to 0. So minus 1 is equal to 0. Alright, so 2 minus lambda is squared is equal to 1. So then square root both sides. So 2 minus lambda is equal to plus minus 1. So lambda is equal to 1 and lambda is equal to 3. So we have two eigenvalues. So I'm going to put it right here. We have eigenvalues 1 and eigenvalues 3. From the eigenvalues, as I told you, the computer takes your fixture, convert it to eigenvalues, and then convert it to eigenvectors. Now we're going to convert this one to eigenvectors. So twice because I have two eigenvalues. 2 minus lambda minus 1 minus 1, 2 minus lambda. So this one I'm going to do it for when lambda is 1, when lambda is 3. So I have two eigenvalues, don't forget that. So if you replace it by 1, you replace it by 1, you replace it by 3, you replace it by 3, what do you get? You get 1 minus 1 minus 1, 1. And then you get minus 1, minus 1, minus 1, minus 1. Now you have to do AB equal to x. So 1 minus 1 minus 1, 1, xy equal to 0, 0. So minus 1 minus 1 minus 1 minus 1, xy 0, 0. Alright, now x 1, 1 is equal to 0, 0. So you have x minus y is equal to 0. You have minus x plus y equal to 0. So what do you have? X equal to y. So your eigenvectors would be 1 and 1. These are your eigenvectors. Now we have to normalize the eigenvectors. So you bring it over here, and let's see, 1 squared plus 1 squared, it would be square root 2. So you have 1 square root 2 and 1 square root 2. Let's do the same thing over here. Let's see what happened. So you have x minus 1 plus y minus 1 is equal to 0, 0. So you have minus x minus y is equal to 0. You have minus x minus y is equal to 0. So this scenario is a little different than this scenario. What if x is negative 1, y is 1? So x is negative 1, y is 1. So normalize it. Negative 1 squared plus 1 squared. So you have a square root of 2, right? So you have negative 1 over the square root of 2 and 1 over the square root of 2. Now we're going to write down this because we have the A transpose A, I believe. So we can go ahead and write it down right here. So A transpose A is equal to V. V is the vector. So we have 1 square root of 2, 1 square root of 2, and then minus 1, minus 1 square root of 2. So now, so that the sigma squared. So let's understand that the sigma squared is equal to lambda. And lambda we have eigenvalues 1 and eigenvalues 3. So sigma is the square root of lambda. So then sigma is the square root of 1 and sigma is the square root of 3. Alright, so we have square root of 1, square root of 3, 0, 0. And then V transpose, so we're going to transpose this one. So if you transpose this one, the row become column and column become rows. So 1 over the square root of 2 minus 1 over the square root of 2, 1 over the square root of 2, 1 over the square root of 2. Alright, now we want to find from here to here, because this is V transpose, but we need V transpose inverse. 1 over the square root of 2, 1 over the square root of 2, minus 1 over the square root of 2, 1 over the square root of 2. So we want to convert it to VT inverse, and this is the augmented. How are we going to do that? So 1 is square root of 2, 1 is square root of 2, negative 1 is square root of 2, 1 is square root of 2, and identity matrix would be 1, 0, 0, 1. So we're going to have to swap it. This is going to come over here, and this ugly stuff going to go over there. Okay? So how can we do that? This is going to be easy. Alright, so remember, this one has to be 1, this one has to be 1, this one has to be 0, this one has to be 0. That's our own goal, end goal. So let's multiply this one by square root of 2. So if I multiply this one by square root of 2, 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 what do I get? I get 1, I get 1, I get square root of 2, I get 0, I get negative 1, I get 1, I get 0, I get square root of 2. Wow, not too bad, not too bad, not too bad. Alright, but remember, this one has to be 0 and this one has to be 0. So in order to make this one 0, what can we do? In order to make this one 0, let's first make this one 0. Making this one is 0 is easier. So we have to add both, then we can easily make this one 0. So add both. So I have 1, 1, square root of 2, 0. 1 minus 1 is 0. 1 plus 1 is 2. this plus this is square root of 2, this plus this is square root of 2, okay? And now I have what I have, 1, 1, 0, 2, square root of 2, 0, square root of 2, square root of 2, okay? Alright, so we are very close. We are very close, right? Yeah. So we have to make this one 0 and this one 1. So let's make this one 0. So how can we make this one 0? But I think we can make this one 1 by dividing this by 2. If we divide this everything by 2, then what do you get? We get 1, 1, square root of 2, 0. Divide this one by 2, 0. Divide this one by 2, 1. Divide this one by 2 is square root of 2 over 2. Divide this one by 2 is square root of 2 over 2. Alright, so now only one job is to make it 0. If we have to make it 0, we have to do multiply this one by negative 1 and add this one with this. So multiplying this one by negative 1 and adding this one with 1 would leave us what? So this one would be gonna be 0. Let's see, this one is 0, this one is negative 1, this one is negative square root of 2 over 2, negative square root of 2 over 2. So if I do that, so 1 minus 0 is copied in 0, 1, oh voila, 2 is square root of 2, 2 is square root of 2. 2. So this is what we have. Now what do you need? We need A. A is mu V mu sigma V transpose. Do we have V transpose or do V transpose? Sigma, we have sigma. We don't have mu. So let's find the mu. Mu is matrix V transpose inverse and sigma inverse. So U is A is 1 minus 1 0 1 1 0 V transpose inverse, we have square root of 2 over 2 minus the square root of 2 over 2 is square root of 2 over 2 and square root of 2 over 2. And sigma inverse is 1 0 0 1 over square root of 3. Now we have to do multiplication. We have 3 matrices, we have to do multiplication. So let's do the this one and this one, and let's come from right to left. Right to left, we have to do the column. Alright, so let's see what I mean by column. So we have to so the one multiply by this column multiplied by the 1. So what do you get? Square root of 2 over 2 and square root of 2 over 2. Right. And this whole column multiplied by 1 over square root of 3. Then we get negative square root of 2 over 2 square root of 3 and square root of 2 over 2 square root of 3. And don't forget, we have to still multiply it with A. And the A is 1 minus 1, 0, 1, and 1, 0. This is the mu. Now, the best thing would be to go left to right. Left to right. If we do that, we do the row. So let's write the final answer. In order to write the final answer, let's just make sure we don't make any mistake. We write 1 minus 1, square root of 2, 2, minus square root of 2, 2 square root of 3, square root of 2, 2, square root of 2, 2 square root of 3. Alright, so this one minus this one is 0, so the first one is 0, so we're going to write 0 over here. So we have 1, 2, and 3, because this is 3 by 2, and this is 2 by 2, so this is 3 by 2 matrix. Okay, 3 rows, 2 columns. Okay, and this one minus this one would be So 2 is square root of 3 minus 2 is square root of 2. So minus 2 is square root of 2, 2 is square root of 3. Alright, now 0, 1, 0, 1. So we need 0 of the first row and 1 of the second row. So 2 now it's become easy. 0 of the first row and 1 of the second row. So square root of 2 over 2, square root of 2, 2 is square root of 3. So square root of 2 over 2, square root of 2 over 2 is square root of 3. Alright, now we're done on 1 and 0, 1 and 0. So we need 1 of the first row and 0 of the second row. So 1 of the first row and 0 of the second row. 1 of the first row is square root of 2 over 2 minus square root of 2 minus 3. So square root of 2 over 2 and minus square root of 2 over 2 is square root of 3. So is this a 3 by 2? 1, 2, 3 and 1, 2. Yeah, so that's right. So now remember what was our goal. Our goal was we can erase everything except this part. We need this part. So our goal was to find A is equal to mu sigma V transpose. Alright, so we have that A. A is 1 minus 1, 0, 1, and 1, 0. And mu is, we just found mu. Mu is 3 by 2 matrix. 0, 2 is square root of 2 over 2 is square root of 3. Is square root of 2, negative square root of 2 over 2. Is it negative square root of 2 over 2? I think positive square root of 2 over 2. And square root of 2 over 2 is square root of 3. And this one is the square root of 2, 2, and negative square root of 2, 2 is square root of 3. Alright, this is our mu. And our sigma is square root of 1, 0, and 0 is square root of 3. And our V transpose is 1 over the square root of 2, 1 over the square root of 2. We don't need it anymore. Negative 1 over the square root of 2 and 1 over the square root of 2. And then I'm going to multiply this one. Let's use the computer to multiply this one. This one, and the result is 101. So this is A. A is 101 and negative 1, 1, 0. Negative 1, 1, 0. So our A is 101. Our A is 101, negative 1, 1, 0, which is equal to 101, negative 1, 1, 0. I hope you understood and appreciate the singular value decomposition.